drafting today. Now some of you might be wondering why mechanical drafting, what's the point? And the big thing with drafting is that it saves a lot on cost. If you're designing a 3D part, such as, some of you, Maya here is building a solar panel, like a frame for the solar panel, buying the wood or steel or whatever material it takes to build this, it costs a lot more money than pen and paper and ink. And so a lot of times when we're just working on our ideas, we'll draft it on paper, kind of test out this idea first, and that saves a lot. You also, there's kind of a hierarchy when it comes to engineering in terms of who's creating the idea, and then like this idea gets shipped out, sent out to lots of different levels to get approved, and then eventually it gets to the constructor. So you want to have your design be clear and easily communicable to the technician or the builder, whoever is actually bringing your project to life. And so the last thing you want is some dude like this who is confused about whatever this hammer is, He's probably reading your blueprint and just doesn't know what to do. So one type of mechanical drafting that we can do is called orthographic projection. Those sound like two really weird words, like really hard to swallow. Can anybody tell me what they think? Can anybody tell me what projection means? What they think a projection is? Nobody wants to give it a try. What's this guy up here? What's this thing bringing?
Projector.
Yeah, this is a projector. And so a projection, when we're thinking of drafting, we can think of it as you're taking a view completely from one certain angle, and you're just drawing what you see from that angle. So it's like if you just shined a light on this object and then just saw what the light touched. And so I'll go into this in more detail. Orthographic projections, your goal is to take a 3D object and portray it in 2 dimensions. It always includes the top of the object, the front of the object, and the right side of the object. If your object is weirdly shaped somehow so that those 3 angles don't get all of the information that it needs, sometimes people will include an isometric side, which I will go into detail about what that looks like, or it'll include the back or the bottom. Now, in different orthographic projections, we have a lot of different customs because, there are a lot of different cultures in the world and people do things differently. So internationally and in Europe, people use what's called first angle projection. In the US and in Canada, so what we deal with, I think, we are in the US, right? We're going to deal with something called third angle projection. Now, first angle projection is shown in this quadrant up here. It's going to be as if you're viewing this object from this point and from this point. And then what you see on these sides get projected onto the screen here and here. And so when you're making a first angle projection, your object, front object, is going to be located here. The right side of your object will be located to the left. And then the top of your object will be located below it. That sounds really, really counterintuitive. And luckily, you guys won't have to deal with that because we're in the US, which uses third angle projection, which I like much better. Because as you can see, if you're viewing from here and from here, and the views get projected onto this screen and to this screen, the top of your object gets placed above the object, and the right side of the object gets placed to the right. That should make a lot more sense, and it should feel a lot more comfortable to you guys. Now, just to see it in use, here is an example that I've created. You guys might recognize this as a 9-volt battery. I think some of you might have been using these this week. So, as you can see, the front of the object is over here, the top of the object is located above it, and the right side of the object is located to the right. Now, can any of you tell me whether this is a first or a third angle projection? Yes, this is a third angle projection because it feels much more comfortable. The top is at the top and the right is at the right. Now, as you might have remembered, I said that sometimes you can include an isometric view of the object as a bonus, and so that's what I've included here. An isometric view, as you can see, is if you've taken the object and just rotated it so that you're viewing it from the top front. And so if you take this 9-volt battery and you're looking at it from about here, that is what you would see. So that's called an isometric view. Here's the same example. This is the first angle projection now. Has anybody figured out like a really easy way to tell the difference between first and third angle? Yeah, and so it's just that third angle, as I've said, should feel a lot more comfortable. The top is at the top and the right is at the right. Sometimes people don't use orthographic projections, so they want to, show an object that might be way too complicated to show just in the two-dimensional projections, and they'll just draw these isometric views of the object. So these are some examples of parts that have been shown in isometric view, and as you can see, there are some dotted lines and some thick lines. Now these are conventions that are very important to consider. They're called line weights, and people use sort of different conventions based on where you are, but the important thing is to remain consistent. And the important things to kind of portray are hidden lines and visible lines. Those are really the most important, because as you can see here, this is just showing what is behind this sort of top part up here. Make sense? So dimensions and scaling, this is super important, because if you put all this effort into this model and you just like hand this picture off to a builder and you don't have any measurements, any dimensions, it's totally meaningless. He's gonna make something that might be like a 20th of the size that you wanted, and so make sure to include your dimensions, and also make sure to include units. Because the last thing you want to do is have all these numbers and then have some dude build it in meters instead of inches, It prevents mistakes and misunderstandings. And so a lot of times formally we'll have a dimension picture portrayed in isometric view like this, where you've labeled, all the sides, all the different parts. And then in other times, sometimes we'll use the same orthographic projections and just have the dimensions as shown here. The important thing is just to make sure that your dimensions are fully defined, and so you have every aspect of your object actually labeled. For example, in this orthographic view, if I had forgotten if I had forgotten to label this side, nobody would know how big to actually make that. And then this is just an example of why dimensioning is important. Can you guys hear? Okay, we'll come back to this. Okay, and all of this is relevant because a lot of you will be using 3D modeling to create drafts of some of your projects. And so the software that we all use here is called Sketchup. It's like ketchup, but with an S at the beginning. You guys can just Google it and download it. It's totally free, which is why we like it. I'll give you a demonstration of how to use the software soon. The important thing to note when using Sketchup is that we are using it in combination with the MakerBot Replicator 2, which is a 3D printer that prints by using something called stereolithography, which is like, it takes plastic tubing and kind of lays it out onto a platform, like so. And the platform kind of moves, and this thing kind of moves. But the thing is, you can't create hollow objects using this, because you can see that if you have a pen moving like this, and it's just spitting out plastic, and you have a platform down here, it can't print in the middle of the air. You can't have it print on something that isn't there. And so, what I have here, I've shown two things that were printed using the MakerBot. This thing was just printed from bottom up. And so the printer was able to print every next cut of the object on top of another piece of the object. But in this version, this cone was printed sideways. And so the person actually had to build all of these fillers and sort of chop it off afterwards, because these are supports for the plastic pen to print on top of. Does that make sense? This is really important to note, because if you guys end up printing something and we haven't planned it through properly and you're trying to print on top of empty space, your thing's going to look really deformed and sad, and it's going to be a waste. So don't do that. And finally, something to note is that the MakerBot Replicator 2 only takes in certain file types, and so the file type that automatically gets created in Sketchup isn't supported by the MakerBot, so you actually have to download an extension. I think it's just called like Sketchup STL, and then you export something called an STL file, and then you can print and go. And so I'll go through that in more detail soon. Does anybody have any questions before I move on to a demonstration? No? Okay. So what we have here, I've opened up Sketchup, and as you can see, I have the 9-volt battery that I showed you in the PowerPoint earlier. And so you can use something called the orbit tool. You can look at it from a lot of different angles. This is why 3D modeling is cool, because if you're building something for a customer and you need to show them the design and they happen to have the software that you have, this is really, really clear. You can just take this, bend it over, and they can look at it from every single angle. And so in terms of actually using this, let's create a new file. Technical difficulties. Okay, so this is what a new file looks like when you open it in SketchUp. I've chosen, there are a lot of different kind of molds or automatic formats in SketchUp. If you select the thing that is 3D printing, then it'll actually give you the dimensions of the MakerBot Replicator 2X. So this is really useful because this happens to be the printer that we use. And so you can just print inside this box and you'll know that it's the right size for our printer to be able to print out for you. So that's really, really nice. Now let's just make something. I'm just going to draw a cube. So automatically, when you first draw a shape in SketchUp, it'll draw it on the red and green plane. So you can see there's a red and green axis here. It draws the rectangle on that plane, right? And now you can use something called the push and pull tool to take that shape and then bring it out a certain distance. And so you might have remembered that I talked to you guys a lot about dimensioning earlier. It's really, really important in Sketchup to pay attention to dimensions as you're making them. Because after the fact, since I've already made this project, I can't alter the measurements of it. As you can see, it's like really annoying. It's just super annoying to deal with. And so I'm going to delete this. Piece by piece. That's fine. I'll be the guy. And so when you're designating dimensions, you need to pay attention to this thing down here. Can everybody see this? There's a dimensions text field for you to enter. And so it's actually different on PC and Mac. On the Mac, which is what I have, I can draw the rectangle, and then I can go back afterwards and edit the dimensions, like so. So I'm going to make it 10 inches by 5 inches, like this. Actually, no, that's ugly. Make it 10 inches by 7 inches. Okay. Okay. On the PC, however, it doesn't let you just draw the rectangle and then edit it. We just, actually Maya and I just discovered this today. And so what you want to do is
you have to draw it, and then before you click it to make the rectangle actually there, you have to just type in the dimensions.
right. So as you can see, when I draw a rectangle, I can click a point and then click another point, and that's where it ends. If you're on a PC and you're editing the text inside the dimensions field, you need to click a point, and then as you're dragging at this point, I haven't clicked yet, you need to enter the new dimensions. You don't do that on Mac, so that's why it didn't work this time.
It works on the Mac.
Oh, really? Oh, it might be a setting that you can just change. No idea.
I always do it the other way.
Okay. Good to know. Well, if you find that you're trying to change the dimensions afterwards and it's not working, it's because the setting is such that you need to draw a point, and then before you click on the second point to finalize the shape of your figure, you need to type in the new dimensions, the dimensions of your shape. And this text box will accept anything that you enter whenever it's relevant. So be careful about accidentally typing in numbers when you're drawing things, because it might just make something you don't want to make. Okay, and then this is called, I've already shown you guys the push-pull tool. There are a lot of things you can do with SketchUp. On the battery that you guys saw before, you can see that there's kind of like a curved fillet on the top edge over here. If you wanted to replicate that, I'll just do a straight one for you guys. There's something called a follow-up tool, which is this little icon over here. And what you can do is you can draw a shape and a curve that you want to follow. So what I've done is I've just drawn this little triangle shape over here. I'll take my cursor to select the top surface. To select the top surface of this cube prism, of this prism. And so what I've just done is I've designated the the edge of this entire prism as my thing to follow. And now I'll select the follow me tool, and then I'll select the triangle shape as the shape that is doing the following. And you can see it kind of cuts all around like that. Does that make sense? So that's like kind of a cool thing you can do to make a lot of your objects look more polished. And the printer will print this because, you know, every layer is on top of another layer. Yeah, so important things to note is that make sure your objects are solid, you know, don't don't make any hollow objects for the 3D printer to print. Make sure all your dimensions are correct as you're making it, because it's annoying to change afterwards. It's doable, but it's annoying. And that's it. Any questions? Yeah.
For the follow feature, can you make it round?
Yeah, I can. So the annoying thing about Sketchup is that sometimes when it makes curved lines, it's not actually one entity. A curved line in Sketchup can be a lot of just like really, really small straight lines. So since my dimensions of this are pretty small, actually they're not that small, maybe it'll work. What's happened to me before is that when I've been doing curved lines in SketchUp, if my dimensions of my figure are too small, like I'm working with an object that's just like 1 inch by 1 inch big, the resolution of the curved line isn't high enough, and so then when you try to pull the object or like use the follow me tool, it's not a closed object. So you get like really freaking weird shapes in space because it doesn't recognize what to do with it. But yeah, so with the follow me tool, I can do an arc. So this is the 2-point arc tool, which means I can use 2 points to designate an arc in a circle that I want to draw. And as you can see, this arc is turning pink. That means that both its tangent, this circular arc is tangent to both of the edges of my prism right now. So I'll double click, that's set. I'll click the surface again, I'll click the follow me tool, I'll click this, and then it goes around. Any more questions? You can also make holes. You can make a lot of things with this. There are a lot of tools to use. You can rotate the thing. No question. You did a really good job. Staff, any questions? Okay. Yes?
How do you take that and turn it into something, like into a file that you can print with?
Oh, yes. Perfect. Okay. So, you guys might remember that I told you that the MakerBot Replicator 2 does not accept the natural file that SketchUp creates. And so what you need to do, okay, so you would want to go to Google and then Google something called Sketchup STL extension. And so, oh, that's really sad. My Wi-Fi isn't working right now. Okay, so once you've downloaded the SketchUp STL extension, which I can't show you to do right now, you'll be able to have this little option in your File tab that says Export STL. So you need to click on that. This dual screen thing is really confusing. Okay, so now you have STL export options. You would specify the units that your object is in, so don't make a mistake here because that's bad. So I'm just going to say inches, or I'm going to say model units because that's what I was building in the whole time. And then specify the file format. This should be fine. And then you would click export. And so you would save it, I don't know, I'll save it under this stuff. Save as. Please, and now once that file is saved, you can easily transfer it to the 3D printer and it's something that I can actually understand. Yeah?
So if you want to make a hollow case, how would you do it?
Well, you would have to get pretty creative. So a lot of times, you can kind of cut the object that you want to make in a lot of different ways, in a creative way, so that you can make sure that every new layer that the printer has to print will be on top of a solid layer. And so, or you can orient the object so that the holes aren't going to be in the way of the printer. So one example is that, like, let's just put a hole through this guy. Say I wanted to print this. There's a hole in this thing, right? If I tried to print over it, by the time the pen that spits the plastic out got up here, it would be printing on top of space. That's no good. One thing that you can do is rotate this object so that it's facing downwards like this, you know? And now the hole is like completely open and it doesn't need to be printed on top of. And so that's a really good question. That's a really good question. There's no set answer. It's something you have to kind of look at case by case and work around based on the options that you have. Any more questions? No? Okay. Who here thinks that they're going to be using Sketchup? Awesome. Awesome. I like Sketchup. It's pretty intuitive. Fun. You guys can come to me if you need help with Sketchup. Okay.